Good morning all. Here we have to find the energy density of a plane progressive wave. So in order to find the energy density, we have to know one equation, that is the equation of a simple harmonic plane progressive wave, which is traveling along the x direction. And the formula is given by y is equal to a sine 2 pi by lambda into vt minus x, where a is the amplitude, lambda is the wavelength, v is the velocity, t is the time, and x is the direction of propagation. Now, what do you mean by energy density of a plane progressive wave? It is just the sum of kinetic energy and potential energy per unit volume of the medium. Okay, so we have to find the sum of kinetic energy and potential energy per unit volume of the medium through which the wave is passing. So first what we have to do is we are going to find the kinetic energy and potential energy, and then we are going to sum it over. In order to do so, what we consider an infinitesimally thin layer, okay, very thin layer of the medium, and which has a thickness dx, which is at a distance O from the origin and of unit area parallel to the wavefront, as shown in a figure. Now we can see that this is the O, this is the infinitely thin layer dx, which we have considered, and it is distance x away from the origin. And here we assume that rho is a density. Okay, rho is a density of the medium. Then the mass of the layer will be, so you can find out the mass of this layer. Suppose it is we have considered as infinitesimally small thickness dx, so we have to find out the mass of this small thickness, and we assume that is dm. It is nothing but rho into thickness dx. So let's put this as equation number 2. Now we, as I told you earlier, we have y is equal to, that's the equation to a plane progressive wave, a sine 2 pi by lambda into vt minus x. That was our first equation, and we all know that what is kinetic energy? Kinetic energy is half mv square. So here we have the mass dm as rho dx, and v, how do you find out v? We have to just, this is the displacement. Equation 1 gives you the displacement. So to find out v, we have to just differentiate with respect to t. So we can differentiate, that is dy by dt is equal to a cos 2 pi by lambda into vt minus x. Okay, and then you have to do with your coefficients, that is into 2 pi by lambda into v. So now we can very well find out the kinetic energy. So this will give it an equation number 3. So kinetic energy will be equal to half, what is a m? M is nothing but your rho dx, equation number 2. Rho dx into 2 pi a into v by lambda cos 2 pi by lambda vt minus x, the whole square. So your result will be half of rho dx 4 pi square a square v square by lambda square cos square 2 pi by lambda Vt minus x. Let's put this as equation number 4. So we have got our kinetic energy as half rho dx into 4 pi square a square v square by lambda square into cos square 2 pi by lambda Vt minus x. Now we can find again. Now we have to find out the potential energy. So in order to find the potential energy, we will first find out the force acting on the layer. And we can very well tell that force into displacement is the work done, and that we can keep it as a potential energy. So this is to find out potential energy. The first step is to find out the force acting on the thin layer, that is dx. So what is the force? According to Newton's second law, F is equal to mass into acceleration. So mass into acceleration means mass into mass into, according to displacement you have d square y by dt square. Mass, you know, it is equal to rho dx from equation 2, and dy by dt you have already found out. What is it? 8 into 2 pi v by lambda cos 2 pi by lambda Vt minus x. Now you have to differentiate once again. So I'll just cut this and bring it here. So you have dy by dt as this. Therefore, d square y by dt square will be equal to a 2 pi by lambda v minus sign. That minus sign I am going to just omit it, because it just indicates that the acceleration is in the opposite direction. So we have sine 2 pi by lambda into Vt minus x, and all this coefficient is 2 pi by lambda into v. So this I can just square it up, because you have to have one more time. Therefore I can write this as equation. This equation, or d square y by dt square, is nothing but equal to 4 pi square v square a by lambda sine 2 pi by lambda Vt minus x. Now what is a sine 2 pi by lambda into Vt minus x? That is nothing but your displacement, the first equation which we started with. So that is equal to y. So we can write d square y by dt square is equal to 4 pi square v square a by lambda square, this is lambda square, into, a is also not there, right? A sine 2 pi by lambda Vt minus x is y. So is my y. Now we have to substitute for the work done. and we have to assume that if the layer is displaced through a distance dy, the work done dW is equal to F dy, and this is equal to 4 pi square b square by lambda square y dy. Into, so I just forgot one thing, this is just the acceleration. Therefore force F is equal to mass into acceleration. Mass is rho dx into, what is it, 4 pi square v square y by lambda square. So I have to have one rho dx also here, right, into rho dx. So this is for a small displacement dy. So this I'll just give it as equation number 5. Therefore, work done for the whole displacement y is equal to, we have to just integrate it, right? So W is equal to integral. So we have to for the whole displacement from 0 to y into 4 pi square v square by lambda square rho y is rho dx into y dy. So this is the variable for here. Okay, so it will be y square by 2. So I'll just write it as 4 pi square b square rho dx by lambda square is a constant, and what is inside the integral is just y dy. So this is equal to 4 pi square v square rho dx by lambda square into y square by 2. So 2 and 2 gets cancelled, and 4 gets cancelled, you get just 2. 2 pi square b square rho dx by lambda square. What is your y square now? Y you know, a sine 2 pi by lambda vt minus x. So y square will be a sine 2 pi by lambda into vt minus x, the whole square, y square. So this is equal to 2 pi square v square rho dx by lambda square into a square sine square 2 pi by lambda into vt minus x. This work done, okay, I'll just put it as equation number 6. This work done is stored as the potential energy. So this equation number 6 is the potential energy. And again you can see that the equation 3, not 3, where's my potential energy? Okay, equation 4 is my kinetic energy. So I can just put all this together. This is the kinetic energy. Okay, one sec. I'm unable to copy it, I believe. So I'll just put it here. This is my equation 7. That's my potential energy here, which is stored as the work done, right? The work done is stored as potential energy. And the other one is, I'm going to my kinetic energy. So as told earlier, we have to add the two together, because total energy is kinetic energy plus potential energy, and it's equal to, so you can see that here also I can just cancel this 2 off here. It is 2 pi square a square. Here also you have v square by lambda square rho dx. That is common here also. Okay. So I can just put it together, take it outside. 2 pi square b square rho square dx into a square by lambda square. So what do you have inside? It is cos square 2 pi by lambda bt minus x plus sine square 2 pi by lambda into bt minus x. So cos square theta plus sine square theta is nothing but 1. So you have that energy as, you get it as equal to 2 pi square v square rho square dx a square by lambda square. That's the total energy of the layer. Okay. Now this will give it an equation number 8. Therefore, energy density is the total energy per unit volume of the medium, and is obtained by integrating the equation 8 from x is equal to 0 to 1. So what is your energy density now? Is equal to integral 0 to 1 2 pi square v square a square by lambda square rho square dx. So you can see that all these are constants. These are all constants, and your integral dx is nothing but x. So for 0, if you put x is equal to 0, it is 0, and if x is equal to 1, it is 1. So your energy density is now equal to 2 pi square v square a square rho square by lambda square. So please learn this. Quite an important derivation, but very easy one. Only thing that you have to know that the displacement of a plane progressive wave, or we can say that the equation for a plane progressive wave is y is equal to a sine 2 pi by lambda into vt minus x. So thank you all. Thank you very much.